Hi everyone, today we are going to study the selective repeat ARQ protocol. The selective repeat ARQ protocol increases the efficiency of the bandwidth of the channel. In this method, receiver has a window with a buffer that can hold multiple frames sent by the sender. So the buffer is big enough to accommodate multiple frames that have been sent by the sender. The receiver will retransmit only that frame which has some error and not all frames as in go back and ARQ. So in our last video when we studied go back and ARQ, we saw that if a sender was sending frames like frames from frame number 0 to frame number 4, and if there was an error in frame number 2, then the frames from frame number 2 till frame number 4 were retransmitted. That means not just the frame in which there was error, but the frame in which the error had occurred. From that particular frame in which the error had occurred till the last sent frame, all those frames were repeated, or all those frames were retransmitted, which was obviously decreasing the efficiency of the bandwidth. Right, because this was not required. You just need to send that frame or those frames which have error, not just all the frames from the frame which had error till the last sent frame. But we were doing this only in go back and ARQ. So I mentioned that we will study a protocol named as selective repeat ARQ, which will overcome this problem of the go back and ARQ protocol, right? So this major issue that retransmitting all the frames from the frame where the error had occurred till the last sent frame was a sheer wastage of the bandwidth, which was not required. So here the sender will retransmit only that frame which has some error and not all the frames, unlike in go back and ARQ. So if you are sending frames from frame number 0 to frame number 4, and if an error occurs in frame number 2, then you will retransmit only frame number 2 and not all the frames from frame number 2 till frame number 4. So that is the reason it is named as selective repeat ARQ, because you are selectively repeating the transmission of the frames. You are selectively retransmitting only that frame which has error. Here the size of the sender and receiver window will be same. So both the sender and receiver window will have the same buffer size, unlike in go back and ARQ where there was no such compulsion and both the sender and receiver window could be of different sizes. The receiver will not look forward to only one frame as in go back and ARQ. Now we saw that in go back and ARQ protocol at any given point of time the receiver was looking forward to only one frame. But here this is not the case. Here the receiver will look forward to a continuous range of frames, that is more than one frame. The receiver also sends narq. Now narq here means negative acknowledgement. So the receiver also sends a negative acknowledgement for the frame which had the error. In go back and ARQ protocol, we saw that the receiver did not send any acknowledgement for the corrupted or out of order frames. It sent acknowledgement only for the frame that was without any error and in order. Only the acknowledgement for such frames was sent. And for any corrupted or out of order frames, it just discarded them without sending their acknowledgement. So what the sender did, the sender waited for a certain period of time, and after its timer went off, it repeated the transmission of that particular frame for which acknowledgement did not come. But here the receiver sends a negative acknowledgement for even for those frames that have error, which basically means that this sender is required to retransmit the frame. And in this case the sender retransmits those frames even before the timeout event fires. So even before the timer expires, the sender has actually retransmitted the corrupted frames, which is again an efficient usage of the bandwidth because you're wasting less time in waiting. Here also each frame will have a sequence number. So now just like the go back and ARQ protocol, here also a sequence number is attached to each frame to be able to uniquely distinguish each frame from the other frame and to be able to identify whether a frame received is a duplicate frame or not. If the frame can have k-bit sequence number, then the sequence number of frames will range between 0 to 2 to the power k minus 1. So k-bit sequence number means the number of bits that are allowed in the sequence number field of the frame, right? As you know, every frame will have a sequence number attached to it, and there will be certain number of bits that will be reserved for the sequence number field also. So if k bits are reserved for the sequence number, in that case, the sequence number of frames will range between 0 to 2 to the power k minus 1. So if I assume this k to be 2, so this means that a 2-bit sequence number is allowed for the sequence number of frames. So in that case, what will be the sequence numbers? The sequence numbers will vary from 0 to 2 to the power k 2 minus 1, which gives you 0 minus 2 to the power 2 gives you 4. So which gives you 0 to 4 minus 1, and 4 minus 1 gives you 3. So basically it gives you a range of sequence numbers ranging from 0 to 3. That means what will be the sequence numbers of those frames? 0, 1, 2, 3. Then after that again it will be repeated 0, 1, 2, 3. So basically, as I just said, that for a value of 2, that is, if the value of k is 2, that means if you are allowing 2 bits in the sequence number field, then the numbers will be 0, 1, 2, 3, 0, 1, 2, 3 and so on. So it starts from 0 and still 3. Then it again starts from 0 and still 3. So the sequence number of the frames will start from 0 and end till 3. That means how many frames at a time can you send altogether? 0, 1, 2, 3, 1, 2, 3, 4. That means you can send 4. You can collectively transmit 4 frames at any given point of time. 1, 2, 3, 4. And what will be the sequence number of those 4 frames? 0, 1, 2, 3. Once you have transmitted those 4 frames, again the sequence number will start from 0, 1, 2, 3 for another lot of 4 frames. So this is how you will determine the range of sequence numbers, and this is how it will be determined how many frames altogether can be sent by the sender. It depends upon the value of k, which is the number of bits that are allowed in the sequence number field of the frame. Now the size of the sender window and receiver window would be 2 to the power k divided by 2. So again it depends upon k, which is the number of bits allowed in the sequence number field. So if here, like we are taking the example of a 2-bit sequence number, so that means the value of k is 2 here. So that means what will be the size of the sender window and receiver window here? As the formula says, it is 2 to the power k divided by 2. That is, it will be 2 to the power 2 divided by 2, which gives you 4 by 2, which is equal to 2. So the size of the sender and receiver window here will be 2. If the window size is 2 and acknowledgement for frame 0 and frame 1 are, if the window size is 2, then the acknowledgement for frame 0 and frame 1 will be sent to the sender after frame 0 and frame 1 have been received properly, and next the sender would be expecting frame 2 and like this. So this is all about selective repeat ARQ.